Now we are going to start with the detailed study of the functional group, that is the alcohol, right. So as you know, there are many functional groups which exist and which we need to study about. So we are just going through the detailed study of alcohol first. So first of all, you should know that what is the functional group of the alcohol. As you all know that we did in a tabular, that chart which I told you in a tabulated form, that is the alcohol functional group is OH group, right. What is the name given to this OH group? The name given to this OH group is hydroxyl group. This is called as hydroxyl group, and if we look for its members, and one more thing before we start with the members, I want that you should know what is the suffix involved. So what is the suffix? You know that what is the suffix? Suffix is the ending of the name. So in case of alcohols or the members of the alcohol, their name ends with the suffix that is all. So the suffix is all. So just look for the members. When we look for the members, so the first member is of one carbon atom, that is the methanol. Second is the ethanol. Third, propanol. So this is how we can make many members starting with the minimum one carbon atom, and we can go up to, you know that we can extend it to the depending upon the number of carbon atoms in a chain. So first member is methanol, followed by ethanol, propanol, butanol, pentanol, hexanol, heptanol, and you know that how we make these members. So what is the IUPAC for it? So the IUPAC for this member is methanol. For this is ethanol, for this is propanol. So this is how we can write the IUPAC name for the different members of the alcohol. But when we talk about the common name, see this was the IUPAC name, right? But when we talk about the common name, so what is the common name which is given, like what is the method of giving the common name for the alcohol? So that is the alkyl alcohol. That means we need to write the alkyl group, name of the alkyl group which is used in that compound, followed by the name alcohol, right. So for example, here which alkyl group do you get to see? This is methyl, you know that. So the common name for this is methyl followed by alcohol. So common name for it is methyl alcohol. Likewise for this, what alkyl group do you get to see? This is the ethyl group. So the name is ethyl alcohol. And for this is, you get to see the propyl group as an alkyl group. So what name is given as common name? Propyl alcohol. Right. So this is how we can write the name of common names and the IUPAC names of the different members of the alcohol. Now, like as we are just proceeding with the detailed study of alcohol, so you need to know about the reactions which an alcohol undergo, the reactions which are concerned to each and every member. But our main focus will be the ethanol, as ethanol is an important constituent of many compounds. So we'll be taking examples of different members, but please keep in mind that you have to concentrate more on ethanol. At least you should be familiar with all the reactions that ethanol undergoes. So we are just starting starting with the detailed study of ethanol, which is the second member of alcohol. Right. So what is the formula for the ethanol? As I told you, it is C2H5OH. So let us see that how ethanol is prepared. So there are many methods to prepare ethanol, but the basic methods which are used in preparing this ethanol are the two methods. One is the fermentation and the other is hydration of alkenes. Hydration of alkenes. See, though we have different methods of preparing alcohol, but out of them, these two methods are very important methods which are used in industries in order to prepare the ethanol. So first, we are starting with the first method, that is the fermentation. So, do you know that where this method is used, this fermentation? And or what does this term fermentation means? You know that do you know that this ethanol is the major constituent of the wines, beers, whiskies, and what I mean, it is major constituent of the hard drinks which we like drink. So these ethanol is like in the breweries we are preparing this ethanol by the process called fermentation. So how this what is the meaning of this fermentation? Fermentation is actually the breakdown of complex substance into simple substance by the action of enzymes. And who release these enzymes? These enzymes are released by the microorganisms. So what do we mean by fermentation? Fermentation is simply the conversion of complex substance into simple, and like what factor is responsible for this conversion? The factor responsible for this conversion is the enzymes. And who is releasing these enzymes? These enzymes are released by the microorganisms. So if somebody asks you to define fermentation, how you are going to define it? You are going to say that yes, it is a process in which the complex substance just gets break down into simple substance by the action of enzymes which are released by the microorganisms. See, this is the basic phenomena which is used in the breweries for the preparation of ethanol. So let us see that how it is used in the production of the ethanol. So what we do in order to make ethanol, so in order to prepare ethanol by the process fermentation, how we prepare? What we do, we take sugarcane juice, we just extract, you are familiar with the sugarcane, right? So what we do, we just extract the juice from the sugarcane, that is we take the sugarcane juice, what we do, we add water into it and we just heat it. And just make a picture in your mind that you have a tumbler sort of thing and you have a juice and you are just putting water into it and you are just heating it, right? So that means after heating, what you are going to get? Obviously you are going to get a sweet liquid that is called as something molasses. So what is the, what do we get? It is molasses. Right, so that sweet liquid, sweet, thick, viscous liquid, that is called as molasses, which we obtain after heating the mixture of sugarcane juice and water. So now I'll be just writing this equation in terms of the chemical formulas. So what sugar does sugarcane juice contain? It contains sucrose. Right, so which is what sugar is used? It is sucrose, C12H22O11. So what I told you, we have just made molasses, and molasses is just a mixture of sugarcane, the sucrose, sugar and the water. So this is something molasses, right? A thick, viscous, sweety substance that is called as molasses. Now I told you that in order to convert complex substance into simple, we need to have enzymes, and those enzymes are released by the microorganism. So just look at the board, which microorganism act here. So in this case, the microorganism which is involved is yeast. Right, and it is supposed to release certain enzymes. As I told you, it releases certain enzymes which convert the complex substance into the simple ones. So which enzymes yeast secrete? It secretes an enzyme invertase. It secretes an enzyme invertase. This invertase just converts this molasses into a simple substance, and what simple substance do we get? We get C6H12O6, again C6H12O6. See, though you can see that the molecular formula is same, but still the name for these sugars are different. These are glucose and fructose. This question must be knocking your mind that they have got the similar formulas, but still I am writing the different names. So you should know that actually they differ in some aspect. And what is that aspect? They actually rotate the plane of polarized light in a different direction. One is lever rotatory, that rotates on the left side, and one is dextro rotatory, that rotates the plane of light towards right side. That you will be doing in the higher classes. So for this moment, you need to know that there exists a certain difference between glucose and fructose. and that difference is the direction in which they are rotating the plane of polarized light. So that means you need to write two formulas differently, right? So now we haven't got the ethanol yet, right? So that means these or I can say this is not the simplest substance which we get after the conversion of this molasses by the action of this enzyme. That means we can get more simpler substance out of it. So just let's see that what simple substance do we get out of it and how. Now this yeast secrete, like in the early step it secrete invertase, now in this step it secrete in another enzyme which that is zymase, and this zymase actually I'll just write in the capital letters so that you can, so that it is more visible to you, right? So it releases second enzyme, that is zymase. This zymate converts this simple the simple sugar glucose and fructose into a more simpler substance, and that simple substance is ethanol, and along with it we get the carbon dioxide. So as you can see here, we have got a desired product, that is the ethanol, which is the major constituent of hard drinks, as I told you. So this is how we prepare ethanol by the process fermentation. But this method is the preparation of ethanol is not limited to only this method. As I told you, this method is commonly used in the breweries, but in the industries or some other like in the plants or something in other industrial plants where we are making ethanol, so it is not only process. See, so we have got another process, that is hydration of alkene. Right. See, this is by the process fermentation we can prepare only ethanol, but by the by this process hydration of alkene we can prepare any alcohol, right? Suppose I wish to prepare the first member of alcohol, that is methanol. So that means what alkene I should be taking here? I'll be taking the same members, right? Suppose I need to prepare ethanol, so what alkene I'll be taking? I'll be taking ethene. If I wish to prepare propanol, then I'll be taking the same carbon atom member in the the carbon atom member of alkene, that is the, like I told you that I want to prepare propanol, so that means I'll be taking propene, butanol, then butene, pentanol, then pentene. That means the number, you can say the member which I wish to prepare for the alcohol, the member with the same number of carbon atoms I'll be using in case of alkene. So by this method we can prepare only ethanol. Right, but by this method we can prepare any alcohol, any member of alcohol. Just it depends like what is the what gets changed actually. The member of alkene gets changed. Like when you wish to prepare the fourth member of alcohol, you need to take the fourth member of alkene. If we wish to prepare sixth member of alcohol, we need to take sixth member of alkene. And moreover, there is one limitation, as we know that the members of alkene starts with the second member, that is the ethene, propene, butene likewise. So this method is not suitable for making methanol, as there is no or you can say there is no member of alkene which contains one carbon atom. So their members start with the minimum 2 carbon atoms. So that means we can prepare alcohol with the carbon atoms 2 or more than it, right? But we cannot prepare the alcohol with 1 carbon atom. So now what is the basic which is involved in this reaction, or what is going to take place? So that means in this reaction what we will be taking, see, we will be having a double bond, alkene, hydration means addition of water. I have just split H2O in H and OH, right? So what is going to happen here? And one more thing, in this reaction take place in presence of concentrated acid, probably a weak acid, right? So what happens? When we just add into this H gets attached to this carbon atom or either of it, and this gets attached to one OH. So that means what does it form? It forms CH and the bond gets single, and to see OH gets attached. Like I took an example just to show you that this contains a double bond. Now I'll be taking the example which will show a proper molecular formula. Suppose I just wish to prepare ethanol, right? So that means this is clear that I need to take ethene if I want to prepare ethanol. So suppose I have taken ethene. This is ethene, you know. I am adding water to it. That means I am adding H and OH to it. I'm just writing it separately because I just want you to understand that how it gets split, this water gets split into hydrogen and hydroxide ions, and how these like groups attach to this thing, ethene. So what happens? This H attached to one carbon atom and this OH attached to one carbon atom. So what happens? That means CH2, CH2, this is, it was previously CH2, CH2, so just I wrote CH2, CH2. Here we have double bond. Suppose for this moment I am just putting double bond, right? So what happens? This H attached here gets attached here and this OH gets attached here. Now just look at for the valency of for the carbon. So how many valencies are stabilized in this case? See, it has got 2 hydrogens, 1 hydrogen, 3 and 2 bonds with carbon. That means 5 valencies. Do you think that carbon exhibit the pentavalency? No, it has the tetravalency. So from where you are going to reduce the valency? Obviously you are going to reduce the valency with this bond. And moreover, the basic of this reaction is this, that whenever we need to add something to a compound, the addition reaction occur only in case of unsaturated the compounds. It doesn't occur in a saturated compounds. That means a compound need to have an extra bond if we need to link some other some other atom with it, right? So this is what we have done. See, it has the double bond. We are just adding into it. When we are adding, they are just losing their one bond, and the lost valency or lost bond is just made with these new groups. So this is what we get, the ethanol. If I just sum up this, what it comes out to be? C2H5OH, and this was our desired product. And one more thing, do you think the reaction will occur as such? No, because I didn't wrote that I said that this reaction take place in presence of concentrated acid and probably the weak acid. Because I didn't wrote anything on the arrow, that means the reaction is not going to take place. So it is compulsory that you need to write the concentrated weak acid. Suppose I am taking a phosphoric acid, you can take any weak acid. So this is how the reaction is going to take place. But one more thing you have to keep in mind when you are using acid here. See, the sulfuric acid is a strong acid, you know that. And moreover, like if you just write here concentrated sulfuric acid, the reaction is not going to take place. The reason is that the concentrated sulfuric acid acts as a dehydrating agent. It is a powerful dehydrating agent. What property it possesses? It possesses the property that it can absorb moisture from the air. So that means when we'll use concentrated H2SO4 here, it is just going to imbibe this water, absorb this water. And when there will be no water, what is going to happen? The reaction won't take place. We will not get our desired product, that is the ethanol. So that means it is clear that you need to use acid here. And which acid? Probably it should be a weak acid, not the concentrated sulfuric acid in any case, because it is a powerful dehydrating agent. So wherever the dehydration is necessary, you can use the concentrated sulfuric acid because it is a powerful dehydrating agent, but not in this case, because here we need to add water. We don't need to remove this water. So that is why we have just done this way. Now I'll be just explaining you this hydration of alkene. As we prepared ethanol from it, I'm just now going to prepare propanol from it. So just to show you that how we can prepare other members other than ethanol from this method. See, if I wish to prepare the propanol from it, so obviously I told you the same member of alkene is to be used. So propanol, so that means which member of alkene I'll be using? Propanol, so it should also be prop member. And what prop member of alkene? That is the propene. See, so how I'm doing? So I'm just writing propene here. You know how to write propene. Prop means 3 carbon, ene means on the one carbon it is double bond, all other are single. I'm just satisfying the valencies. So this is something that is propene. Now I am adding water to it. And again the weak acid presence is here. So what happens? That means H and OH is going to add into this propene now. Now where this H and OH gets added? So it should be clear in your mind that we can add any substance across the carbon, only that carbon which is bonded by an extra bond. So that means addition reaction can take place only between these carbon atoms. It cannot take place between in this bond. It should means the carbon atom which wants any substance to get linked with should possess an extra bond, and in this formula where you get to see an extra bond, obviously between this carbon and this carbon. So what is going to happen? This H is going to attach here and this OH is going to attach here. Now, like I've told you that this H is going to attach to the middle carbon and this OH is going to attach with the terminal carbon. Now what is the reason behind? Do you have any idea why I'm telling you that you need to attach this kind of thing in this case? But I didn't told you this point here. I just told you wherever you can attach the H and OH in case of ethene. But when we are talking of propene, I'm telling you that it is necessary that you attach H to the middle one and OH to the terminal one. The reason is that if you will attach this H to this, what product you are going to get? You are going to get, suppose OH is just getting attached here. So we have CH2OH, H is going to attach here, CH2 and here is CH3, right? And if I attach these with this in a different manner, so what I'm going to get? I'm going to get CH3, CH, OH and CH3. Right. So what we wish to prepare, what I told you that which product I want. I told you that I want propanol. Propanol means prop 1 all. That means alcohol group is attached to the first carbon atom. And what is the IUPAC name for these products? It is propanol because all is attached to the first carbon atom. But in this case, OH group is attached to the second carbon atom. So that means it is not a propanol, it is propan 2 all, or you can say it is 2-propanol, but it is propanol. That means at first position there is OH group. So that means it actually matters where you attach this H and OH. So if you get a question like that, if you have a compound which has the carbon atom more than 2 and you need to add something, so just look at the desired product what you need, because the positions of functional group or substituent actually matters, and this just change the compound, like it is propanol and it becomes 2-propanol. So there is a difference between the propanol and 2-propanol, right? So whenever we are just want to prepare 2-propanol, then do it this way. And if you need to prepare as propan, that means the carbon atom carrying the functional group or substituent at first position, then you need to do in this case. That is why I told you that when you add H and OH, add H to the middle carbon and OH to the terminal carbon. This is why it is necessary to concentrate here when you are just reacting the alkene with the water. So, right. So this was the reason that I just framed an example for the the third member. This is how likewise you can do it for the fourth member, fifth member. So just get to know first that which product you desire. So because it matters a lot when you get attached these atoms to the compound. So I think you are just familiar about the preparation. So first method is fermentation. This is the method which is strictly used for the ethanol, not for any other alcohol, and this method is commonly used in breweries, right? The second is hydration of alkene. This method can be used to prepare any alcohol. 2 points you have to keep in mind. One is that you need to take weak acid, because in presence of concentrate weak acid, the reaction is going to take place, otherwise the reaction is not going to take place. The second point is that if you wish to prepare methanol, propanol, butanol, hexanol, any member, so you need to take the same member of the alkene, right? Means the same member which has the same number of carbon atoms in it. And what we are doing in this, we are just adding water, and it is just showing a type of addition reaction and this forming the desired product. So this is how we do the preparation of alcohol. Now we will be taking up the properties involved.